Warm welcome and greetings to my dear students, friends. Today we are going to see a topic on the Mohr stress circle method to find the principal stresses and the principal strain and also the maximum shear stress. So this is coming under the strength of material or the solid mechanics, either in the third semester or fourth semester. All of you know that the normal stress, shear stress, and also the principal stresses. So in the case of two-dimensional structural elements, uh, uh, we have the sigma x and sigma y, that is the normal stresses in the plane x and y. I am taking a plane xy only. Similarly, you can take the yz plane or zx plane. So I am taking the xy plane. So sigma x and sigma y are the normal stresses acting on the plane. Similarly, tau xy or tau yx or the corresponding stresses acting on strained material. So these normal stress, the shear stress are producing the principal stresses on a two-dimensional structural elements. In the case of a beam element or in the case of a slab element, it is nothing but two dimension because the thickness is very small compared to the longitudinal axis or the length of the beam. So that's why it is called as a two-dimensional elements. So here, if you are taking on any plane, you are able to find the normal stresses and the shear stresses. We call it as sigma x, sigma y, tau xy, or the tau yx for the two-dimensional plane. We can able to find the principal stresses. I call it as sigma 1 and sigma 2. These are the principal stresses acting on the two mutual perpendicular planes in which there is no shear stress in that plane. So then only we call it as a principal plane. So a principal plane is a plane where only the bending stress are present, that is the normal stress, and the shear stress will be a 0 or a nil value. I am taking sigma 1, sigma 2 are the major and minor principal stresses. So in the case of analytical way, you can find the major principal stress sigma 1, sigma 2 with the help of the normal stresses and shear stresses. The major principal stress or the maximum principal stress is denoted by sigma 1. So that is equal to sigma x plus sigma y divided by 2 plus square root of sigma x minus sigma y by 2 the whole square plus q square or tau square, where q and tau are the shear stresses acting in the plane. Sigma x and sigma y are the normal stresses. In the case of a plane, we are taking xy in 2D. Similarly, the minor principal stress, sigma 2 or sigma minimum, can be taken the equation of sigma x plus sigma y by 2 minus square root of sigma x minus sigma y by 2 the whole square plus tau square or q square. Already I have said that q or tau is the shear stress acting on the strained material plane. So this is an analytical method. Similarly, you can able to find the case of the graphical method, that is called as a Mohr stress circle method. We are taking the two axes x and y with the intersection at point O. So we have to plot the normal stresses in the horizontal direction, that is in the x direction, and the coordinate, that is ordinate of y axis, you have to put the shear stress. Once you know sigma x, sigma y, and the q can be taken, we can able to draw a Mohr stress circle which intercept the corresponding normal stresses in the x-axis. Both sigma x1 and sigma 2 may intercept on the right side of the Mohr stress circle. That means, so it is a tensile stress. So if you are getting as minus value, it is a compressive stress. So on the right side of the axis, we are putting it is a right of both sigma 1, sigma 2 or the tensile stresses. If it comes left hand side of the origin, that is called as a right compressed stress or negative stress value. So from the stress circle, you can also find the corresponding the angle of theta, where the shear plane has to meet the stress circle, right? So from the Q value, right, we are uh, joining with respect to the top and bottom of the horizontal line and taking the intersection on the stress circle as the radius from point C center, and taking as a radius we can draw the circle. So the maximum value in the y-axis, the y coordinate, that we call it as a right maximum shear stress. So the maximum shear stress can be taken from the Mohr stress circle or from the graphical method also. So for that, tau max or Q max is equal to the sigma 1 minus sigma 2 by 2. So that you have to take it as the maximum shear stress. So if the value of the sigma 1, sigma 2 will be of negative, that means that is on the left hand side of the uh, coordinate axis, the horizontal plane. So you can put the corresponding sign convention. If both are tensile, you can put sigma 1, sigma 2, the principal stress, which is of the positive or the tensile stress. So principal stresses are nothing but the normal stresses, and there is no shear stress acting in that plane. So that is called as a principal plane. So it is easy to draw the Mohr circle compared to the analytical method, and you can easily solve the maximum shear stress and also the major and minor principal stresses sigma 1, sigma 2. So this is a graphical method. This is the easiest method compared to the analytical method. So definitely you can use this method, for a short within a short period you can get the answer. And also it is used to find the shear plane, right? So theta 1, theta 2 or the maximum and minor principal plane. So principal plane are the only the normal stress will be present and the shear stress will be nullified or it will be zero. So this is about the most stress circle explanation. So the main point is you can easily find the maximum and minor principal stresses in addition to the maximum shear stress and also the corresponding principal plane theta 1, theta 2, and all the shear plane you can find at any angle, that is a theta value. So this is about the explanation of the most stress circle method, that is called as a graphical method. Thank you very much for patiently listening. You can see it in the next video. Thank you very much.